10 advanced US combat robots redefining war. At number 10, the XQ-58 Stingray. This carrier-based unmanned aerial refueling aircraft extends the range and endurance of managed strike platform. Built for autonomous carrier operations, the XQ-28A asset successfully executes automated fuel transfer to F/A-18, E-2D, and F-35 jets. In a carrier strike operation, it can extend a fighter's combat radius by thousands of miles. However, the Stingray carries no direct weapon loadout. This lack of organic weaponry keeps its impact indirect, ranking it lowest on our effectiveness scale as a force multiplier rather than a frontline attacker. While support assets multiply range, advancing higher requires systems that actively secure information superiority in denied areas. At number 9, the RQ-180 Sentinel. This classified Northrop Grumman strategic reconnaissance UAV operates inside heavily contested air defense, featuring a stealthy flying wing design with a rumored 130 feet wingspan. It carries advanced intelligence gathering sensor at high altitudes. In a near-peer confrontation, the Sentinel penetrates anti-access zone to deliver real-time targeting data on adversary missile field. Yet, the drone carries no offensive payload. This lack of firepower limits its impact to strategic awareness, keeping it ranked below armed platforms. Airborne reconnaissance provides deep data, but persistent maritime tracking expands domain control across vast oceanic battlefields. At number 8, the UCV Seahawk. This 135 feet long medium unmanned surface vessel and weighs 142 metric tons at fuel load and serves as an autonomous sensor platform. Using GPS, radar, and sonar, it tracks enemy surface vessels and submarines. During deployments like RIMPAC 2022, it cruised thousands of miles streaming real-time targeting data to crewed destroyers. However, the Seahawk operates without built-in weapons. This lack of independent lethality and slower surface transit speeds place it below agile armed platforms. To outrank pure sensor vessels, a platform must directly modify the physical battle space to ensure troop mobility. At number 7, the ACES. Produced by Textron for the DARPA's ULCV program, this amphibious robotic engineering vehicle accelerates combat mobility by bridging obstacles without risking human engineers. Built on tricorder chassis, it achieves land speed over 30 meters per hour and swims at 5 meters per hour. Its fully submersible architecture allows it to cross deep river beds to deploy heavy bridge modules under fire. In an amphibious brain scenario, an ACES platoon can establish crossings autonomously to preserve operational momentum. Despite its value to maneuver warfare, the vehicle carries no weapons or sensor. This auxiliary engineering focus keeps its battlefield effectiveness below armed tactical combat platforms. Engineering vehicles secure local river crossings, but controlling strategic ocean corridors demands unmatched maritime endurance and active tracking capabilities. At number 6, the Sea Hunter. This DARPA-developed trimaran vessel features a 132 feet hull and 135-ton displacement, specialized for autonomous anti-submarine warfare. Driven by diesel and electric propulsion system over 27 knots, it sails for more than 70 days across a 10,000 nautical mile range. Its hull-mounted sonars allows continuous tracking of quiet submarines at an operational cost of just $15,000 to $20,000 daily. During naval operation, it can establish persistent area denial across oceanic gaps, allowing crewed destroyer to pivot toward air defense. Nevertheless, the Sea Hunter carries no offensive armament because it relies on data relays rather than direct weapon deployment. It places just below armed combat variants, while persistent maritime scouts provides defensive deterrence, pushing into the top 5 rigorous platform that brings direct kinetic firepower to the front lines. Before we continue, make sure to subscribe so you don't miss the next breakdown, and leave a like if you've been enjoying the analysis so far. Also let us know in the comments what topic we should cover next. At number 5, the Ripsaw M5. This 6.5-ton 5th-generation robotic tank features a steel chassis and crosses large terrain at speed over 30 meters per hour. Armed with remote weapon station like Cross, it can deploy machine guns, grenade launchers, or ATGMs via its 5,000-pound capacity payload deck. In an armored assault scenario, the M5 can advance under fire to clear active minefields using a towed rocket-propelled line charge. This direct kinetic capability immediately boosts battlefield lethality and infantry survivability. However, its armor and operational endurance are fundamentally limited compared to manned main battle tanks. This constraint anchor it mid-table below strategic deep strike systems. Ground combat systems face severe geographic limits, whereas the upper tier of robotic warfare belongs to platforms capable of global unalerted reach. At number 4, the Boeing Orca. This extra-large unmanned undersea vehicle introduced covert power projection to deep maritime domains measuring 51 feet long with a specialized 34-feet modular payload bay. The Orca features an unprecedented 6,500 nautical mile range and executes months-long autonomous operation while carrying up to 80 tons of mission gear. In an undersea combat scenario, it can traverse contested oceans undetected to quietly sit strategic naval choke points, withdrawn loitering mines, or track hostile submarines without surfacing. Its blend of extreme stealth and immense operational reach allows it to outflank adversaries underwater, placing it above the heaviest ground or surface combatants. Despite this strategic advantage, the Orca currently does not carry direct high-speed weapons, relying on latent payload delivery rather than immediate high-velocity kinetic engagement. Keep it positioned just below the rapid strike airborne system in the top tier. Subsurface stealth allows for strategic patience, but true operational dominance requires the high-speed, flexible strike capabilities found in advanced aviation. At number 3, X-47B UCAS. This tailless jet drone features a 62-feet wingspan and low observable stealth directly to carrier flight decks. It revolutionized autonomous naval aviation by proving the core concepts of future air combat, executing history's first unmanned catapult launches, arrested recoveries, and mid-air refuelings. In a high-end carrier strike scenario, the X-47B can integrate into wings alongside crew F/A-18 and E-2D platforms, using its internal weapons bay to transport precision munitions deep into contested airspace without risking pilots. This capability proved that autonomous platforms could operate in strike packs to saturate heavily defended targets. However, the X-47B was never mass-produced and remains a developmental prototype demonstrator. Lacking active deployment numbers, it cannot outrank the active combat-proven platforms leading our evolution. A prototype established future doctrine, but true battlefield effectiveness requires an armed platform with a massive production footprint and thousands of proven combat hours. At number 2, MQ-9 Reaper. This battle-test hunter-killer drone is the workhorse of modern unmanned strike warfare, with over 5,075 units built as of 2026 and roughly 300 active in UCAF service. Powered by a 950 SHP turboprop engine, it operates up to 50,000 feet with an endurance exceeding 27 hours. The Reaper delivers 15 times the payload of the earlier Predator, utilizing satellite communication to deploy a heavy arsenal of Hellfire missile and precision-guided bombs. In frontline interdiction mission, remote pilots can loiter over battlefield for hours to eliminate artillery or armored columns with near immediate response times. While it offers unmatched combat-proven lethality, its low subsonic speed and prominent turboprop silhouette leave it relatively vulnerable in a contested high-end fight. This specific lack of stealth against advanced air defense networks prevents it from claiming the top spot on our list, while a turboprop hunter-killer provides relentless firepower in permissive airspace. Dominating a near-peer conflict requires a low observable jet combining extreme speed, internal weapons, and collaborative artificial intelligence. At number 1, XQ-58 Valkyrie. This stealthy, low-cost attritable jet UAV reigns supreme on our battlefield effectiveness scale because it is purpose-built to survive and dominate near-peer air wars. Operating as a collaborative combat aircraft under the Loyal Wingman Initiative, the Valkyrie features a 3,000 nautical mile combat radius, cruises at Mach 0.86, and reaches altitudes of 45,000 feet. It integrates an internal weapon base alongside wing station, allowing it to transport precision bombs and missiles without compromising its low observable stealth profile. Utilizing fly-by-wire autonomy and AI flight system, the XQ-58 can execute complex formation maneuvers alongside crew F-35 and F-22 fighters. In a high-intensity maritime conflict, fleets of Valkyrie can deploy from short, austere location without runway preparation, flying deep into denied airspace to act as a decoy, deliver automated electronic warfare support, or launch anti-ship missiles against an adversary carrier group. This platform radically alters military doctrine by shifting air combat away from high-risk human sorties toward distributed robotic mass. It easily surpasses the MQ-9 Reaper in high-threat survivability and outpaces experimental demonstrator like the X-47B because its affordable design allows it to mass fielded and risk in combat. Fusing stealth, independent lethal payload, and cooperative intelligence, the XQ-58 Valkyrie stands as the most dominant robotic combat system today. The evolution of autonomous military platforms demonstrated that survivability and collaborative artificial intelligence dictate through battlefield effectiveness, while support assets and maritime sensors lay in the groundwork. Armed aerial swarms like the Valkyrie represents the future of frontline power projection. Which of these robotic combat systems do you think will reshape modern defense doctrine the most? Let us know your thoughts in the comment below. If you enjoyed this breakdown, make sure to like, subscribe, and watch the next video on your screen for another in-depth look at modern military.